And now we can formally begin the class. So we are studying about functions. We have studied why do we need functions, what's their use. At least one of the use that we have studied why we need functions is that you don't have to write the code repeatedly, and whenever you have to modify that code, you modify it only at one place because function is defined only once. Okay, it's defined only once, but it can be called any number of times. Okay, the code that we have written once, we can use it any number of times at any place in our program. Then we also studied a difference between declaration and definition of a function, and why do we need a declaration, and what does a definition do, how do we call a function, okay, what's the syntax of all these things, and then how do we pass information to a function whenever we call it, okay, via its arguments. And then how can a function pass some information back to where it was called from. Okay, so it's a return value that the function can pass back to whoever the caller was, whoever called that function. Okay, so function we can have information can be passed both ways. The caller of a function can pass information to a function, okay, and also the function can also pass information back to the caller. Okay, so the caller of a function can pass information to a function via its arguments, okay, and the function can pass some information back to the caller via its return value. Okay, so that's what we have studied so far. And also in the last class we also studied the concept of global variables versus local variables, okay, and what's the lifetime of global variables and local variables. And when a program is run, it gets different segments allocated in memory. So there's code segment that contains the instructions for that program, the data segment that contains global variables, constant, literals, etc. And there's the stack segment which contains local variables. Okay, so we especially focused on the working of stack segment. How does the stack segment works when a program is running? Okay? And we also discussed a segment called heap, which we said we'll discuss it later. Okay, that's all that we have discussed so far about functions. Are there any questions? So मेरे पास 2020-79 की screen नहीं आ रही. I don't know what this comment means. Why would you like this screen of 2020-79? You are saying about the recording 2020. Oh, I don't know what you are talking about. आपकी screen show नहीं. Okay, so don't worry. I have not shared my screen yet. Okay, so don't worry about that. I'll share my screen shortly. So then you'll all be able to see the screen. So before that, there's a question. क्या global variables को main के नीचे declare कर सकते हैं? It's a good question. I think you can declare it. I mean, from the top of my head, I'll say that you can declare it, but then you will not be able to use it in main. Okay? So if you want to use it in main, you have to declare it before main. Okay, because the general rule in C++ is that you have to introduce any new thing that you want to use in your program. You have to introduce it in your program before you use it. Okay, so introduction is done by declaration for variables as well as for functions. So if you want to declare a global variable and use it in main, then you should declare it before main. If you declare it after main, then you might not be able to use it in main. So give an example of global variables and local variables. I think we, at least for local variables, we had plenty of examples in last class. Okay? So all your function arguments as well as all the variables that are declared inside a function are called local variables. Okay, is it clear, Saleh, the definition of a local variable?
Yes, sir, it's clear.
Okay, global variables, if you want an example, I'll give you an example now. Just let me share my screen with you. So where's that screen that I want to share? Okay, I have shared the screen, but I think this machine is stuck, so I'll have to reboot it. Give me a minute and we will reboot this machine. So meanwhile, while this machine is rebooting, there was a question last time about actual parameters and formal parameters. So I think it was Rishan who asked it. So is the concept here, or do you want me to explain it? What do we mean by actual parameters and formal parameters? Okay, good, very good. Explain it. So, okay, before I explain, there's a question about array को argument में कैसे pass करते हैं. We'll study this next week, okay? For the moment, don't worry about arrays. So let me share the screen and then we'll discuss global variables as well as formal arguments. Just so let me open a terminal. Can you guys see this terminal? Okay, good. So here we have a function called numadd, which takes two integers and returns an integer. And we are calling this function here at line number 16. Okay, and I'll delete all these lines. And we have declared this function here, somewhere here, numadd. I'm sorry, we have declared it above main on line number 6, and we have defined it below main in line number 25 to line number 30. Okay. So here when I call this function, let's say I call it here 55 and 66. Okay. So let's go to the definition. Line 25 to line 30. Does this function have any arguments? Alishba, you asked the question, so kindly answer the question. Does this function has any arguments? Alishba, you can either speak or chat. Okay, very good. So it has, how many arguments does it have? 2. What are the names of these two arguments? Num1 and num2, very good. Okay. So these arguments that we have defined in the definition of the function, they are called the formal arguments. Okay, that's the definition thing. Is it clear? Num1 and num2 are the formal arguments for this function. Okay. Is it clear? Definition of the function, sorry, what are they called? Formal arguments. Okay, good. So now let's see when we call this function on line number 16. Okay. I'm calling this function on line number, which number was it? 16. Okay. So is it taking any arguments on line number 16? Okay. So what are the values of those arguments that we are giving to this function when we are calling it? $55 and $60, very good. Okay. So at line number 16, the actual arguments for this function num add are 55 and 66. Okay. And the formal arguments are num1 and num2. Okay. Now let me add another line. We go to this variable and I and now I'm giving it x and y. Okay. So I'm calling this function again on line number 18. What are the arguments that I am passing to this function on line number 18? X and y, very good. And what are the values that we are passing to this function on line number 18? $45 and $78. Okay. So the actual arguments that we are passing to this function at line number 18 are x and y, or the values 45 and 78. The formal arguments for this function on line number 18 are still num1 and num2. Okay. So the formal arguments are the arguments that are defined in the definition. Okay. And the actual arguments are the values that we pass to the function when we call a function. Okay, is it clear? The difference between formal arguments and actual arguments on both line number 16 and line number 18, the formal arguments remain the same for the function. The actual arguments are different. On line number 16, they are 55 and 76, and on line number 18, the actual arguments are 45 and 78. So whenever we call a function, the actual arguments may change depending on the values that we pass to that function, but the formal arguments will always remain the same. Okay, in this case, num1 and num2. Is it clear to everybody? Difference between actual arguments and formal arguments? Okay, so there's no answer, so I'm assuming it is clear to everybody. So now we will move on to another concept, related concept. This kind of thing that we have studied, passing values to a function. There are multiple ways that we can pass arguments to a function. This normal way that we have studied, first of all, like you declare a variable as argument, and then you can pass a variable or values to that function. Okay, so this type of passing arguments is called pass by value. On line number 18, when I pass x and y to the function, what do you think is actually passed to the function on the stack? Is it the variable x and y or the values contained in variables x and y that are passed to num1 and num2? The values, okay? The variable x and y remain wherever they are. Okay? What happens is a copy of their values is made, and those copies of the values are assigned to num1 and num2. Okay, so only the values are passed. The actual variables remain where they were in memory, in RAM. Okay, so the actual variables are not passed, but rather the copy of the values of those variables is passed to function arguments, or is copied in function arguments. Okay, so a copy is happening. So let's say in my function here, num add, I change num1 is equal to 11, and similarly num2 is equal to, let's say, 2. This line number 31, 32. Okay, it's num1 equal to 11 and num2 is equal to 2. On line number 18, when I call num add, I pass it the value x and y. And on line number 31, 32, and num1 receives the value of x, num2 receives the value of y. Right? And in line number 31, I change num1, and line number 32, I change num2. By changing these values of num1 and num2, does the value of x or the value of y change or not? The value stored in x or the value stored in y change or not when I change the values of num1 and num2? What will be your answer? No. Is it clear to everybody? No, because num1 and num2 are different from variables x and y. Okay, x and y have separate memory location and they have their values stored in that memory location. Num1 and num2 are separate memory locations which contain the copy of the value of x and y. Okay, so if I change num1 and num2 in those memory locations, I am only changing the memory locations for num1 and num2. I am not at all touching the memory locations of x and y. Okay, so the values of x and y do not change. That's because num1 and num2 are copies of x and y, contains the copies of the values of x and y. Okay, they have their own separate memory location on the stack. Is it clear to everybody? Okay, so no answers, I'm assuming it is clear to everybody. Good. So this kind of passing values to a function is called pass by value or pass by copy. Okay, so there's another type of passing values to a function which is called pass by reference. Okay, so but for that we first need to study a new concept called reference variables. Okay, so I'll basically start by giving you what a reference variable is, and then we'll see how we can use reference variables to pass values to function by reference. Okay, so let me give you an example of a reference variable. We will basically start here, x and y, and okay. We'll come to function later, but let's start to.
Sir,
Yes.
can you please remove this whole code because it then become very confusing. Please start it from the start. Write it from the start.
Actually, we will be needing these functions later. That's why I am okay. But if you say we'll remove it and then we'll start again. Okay, so this is a very simple C++ function which does nothing. Is it good? Can we start from here? Okay, so no answer, so I'm assuming yes. So let us start from here. I'll declare a variable which let's say we'll call x32 int y is equal to x. Okay. So now if we change y is equal to 55, is this code clear to everybody what this code is doing? There is noise in your sound. Is it noise for everybody? Okay, so Uzair, you are still having the noise or is it okay now? Okay, so fluctuates. Okay. So bear with me for some time. So okay, yes. So I hope the code is clear. Answer a question which is when I am changing the value of y. Before that, how many variables are there in this code? Two. Very good. Okay. Two, x and y. Okay. So do these do these variables have their separate memory locations or they are sharing same memory? Will their values will be contained in separate memory locations or okay, good. So x has its own separate memory location and y has its own separate memory location. So when I say y is equal to x, what happens? On line number 8, you have y is equal to x. What is happening in that line? X is assigned to y. Okay, very good. It will become 32. Yes, but kindly use technical language because now you are studying technical stuff. So here the assignment operation is happening. Okay, so x is assigned to y. We can still improve it. We can say that the value of x is assigned to y. The value contained in x will be assigned to y. Okay. So values get interchanged. No. Interchange is not a correct word. Interchange means the transfer is happening in both directions. Okay. Here the transfer is happening in only one direction. Okay. Only one value is copying from x to y. Okay. So it's not an interchange. It's a copy or an assignment. It's happening in only one direction. So on line number 10, I am modifying y. Okay. So is it modifying y only, or I mean the question is, when I'm modifying y on line number 10, is it affecting the value of x or not? Only y. Okay, so we are not modifying x because y is a separate variable with its own memory location. So when we assign to y, we are only modifying y. Okay, good. So this is how we declare a normal variable. Now let's see what is a reference variable and what does it look like. So let me declare a reference variable. So declaration of a normal variable is, here we have like normal variable declaration. We can have the syntax is type, name, and optionally we can assignment, optional assignment. When declaring a reference variable, the syntax would be type and this particular symbol after a type which we call an ampersand. Okay, type, then an ampersand, and then we give a name, and then we have an assignment, and this time it's not optional, it is, how do we say, obligatory. Okay? Obligatory assignment. Here it's optional assignment. Okay, so to give you an practical example, we'll say int ampersand, we'll give it a name, let's call it R. Okay? And now we can't just say like this. Okay? We can't declare a reference variable without an assignment. We will have to obligatorily assign the reference variable in its declaration. Okay, we can't have a declaration of a reference variable without an assignment. Okay, so the assignment would be like something equals to, and also here we can't give a literal, we have to give some variable here. Let's say again, we declare this like this. So we have the type, the ampersand sign telling us that this declaration is not of a normal variable but of a reference variable. Okay? And then we give a name to the reference variable, and then after a name we have to obligatorily assign this reference variable to another variable. Okay, initialize it to another variable. Okay, I'll tell you what how it works, but for the moment, is it clear how do we declare a reference variable, the syntax, and the fact that it has to be initialized obligatorily, and on the right side of the assignment operator, we can't have a literal, it has to be a variable. Okay, is it clear? The declaration of a reference variable. I've just stated the syntax. Okay, what does it mean? We'll discuss later. But for the moment, I'm just telling you the syntax. How do we declare a reference variable? So is it clear? How do we declare a reference variable? The declaration is in front of you on line number 14. कोई भी integer assign हो सकता है. I mean, on the both side of the assignment operator, we have to have the same type of data. Okay. So the only difference is it could be any variable on the right side as long as you have the same type on the left side. Okay. The difference with the normal variable is that in normal variables on the right side of the assignment operator, we can have a literal, but here we can't have a literal. Okay, it has to be a variable, and we'll see what's the difference in their working right now. Okay, so somebody wanted to ask a question. Alishba, you wanted to ask a question?
सर ये आपने x असाइन किया है ना r को, तो ये हम सिर्फ कोई वेरिएबल ही मतलब असाइन करेंगे या वैल्यू भी कोई असाइन कर सकते हैं?
Value, you mean literal like 5?
Yes sir.
Ampersand r equal to 5? No, we can't assign a literal to a reference variable, and we'll see why not. Okay, we'll see it right now. Any other questions so far? I'm coming to that. What does changing value of r means? Okay, so if there's no question, we can discuss what does it mean, how does a reference variable is different from a normal variable. Okay? So the answer is that when we declared y on line number 9, int y is equal to x normal variable, so y was a separate variable, was created with its own memory location, and the value of x was copied to the memory location of y. But contrast to this, when we declare a reference variable on line number 14, we are not creating a separate variable. Okay, a reference variable does not have its own separate memory location. A reference variable refers to another variable. Okay, that's why we have to, on the right side, we have to give another variable. Okay? You can, in simple terms, you can think of it as another name for the same memory location as x. Okay, so r is not a normal variable, it's a reference variable, and it will not have its own separate memory space. It will refer to the variable x, okay, which means it refers to the same memory location as x. Okay. So right now here, if I change the value of r is equal to 77 and p print r okay. So what do you guys think will be the output of this code? X, Y, R. What will be the values printed at the end of this code when it is executed for X, Y, and R? 77, 55, 77. Very good. Okay. Because when we change the value of Y, it did not affect the value of X because Y had its own separate memory location and we only changed the value of Y. But when we change the value of R, R does not have its own separate memory location. It refers to the memory location of X. So when we change the value of R, we change the memory location for X also. Okay, X and R basically have the same one memory location. Okay, so that's the difference between a normal variable and a reference variable. Okay, is it clear? What is a reference variable and how does it work? We'll see why is it useful, but for the moment, right now, you should know how do we declare a reference variable. The fact that initialization is obligatory, is compulsory in the declaration of reference variable, and the fact that on the right side of the assignment operator, we cannot have a literal. It has to be a variable because the reference variable does not exist independently. It refers to another variable. Okay, so it shares the memory space with another variable. So R here has to have a variable on the right side of the assignment operator during its initialization or declaration. Okay, and once we have assigned a reference variable to another variable, we cannot reassign it to another variable. Okay, it will always be referring to the memory location of the variable where it was initialized. Okay, so I'll repeat again, a reference variable is different from a normal variable because a reference variable does not have its own memory location. Okay? So when we create a reference variable, when we declare it, we basically assign it to another, or we make it refer to another variable, okay, which we basically put on the right side of the assignment operator. During the declaration of a reference variable, on the right side of the assignment operator, we'll put a normal variable or another variable, okay, and the reference variable will not have its own separate memory location. Rather, it would refer to the variable on the right side of the assignment operator. Okay, so it will basically share the memory space with that variable. Okay. So why is it called a variable? A variable is something whose value you can change. Okay, so a reference variable also, its value we can change. It can vary. That's why it's called a variable. Explain the use. Okay, I'll do it again. So we can assign R any value, but X will always be equal to R. Yes, and vice versa. The value of R will always be equal to the value of X. ये कहाँ स्टोर करेगा क्योंकि x की मेमोरी ऑलरेडी कंज्यूम हो चुकी है. नहीं, कंज्यूम, व्हाट यू मीन बाय कंज्यूम? That memory location for x is storing a value, and R is also referring to the same memory location. So though they both are sharing the same memory location, so any value stored in that memory location will be the value of x as well as the value of y. Okay, so x and R will always have the same value. Is it clear? Okay, so why do we need it? Let's see an example. Here I'll remove this code. And here I'll declare and define a function swap r1 arg1. I want a function which should swap the values of x and y for me. Okay, so let's say this function is called swap, and here I say int temp is equal to arg1. In arg1, by swap, I hope you understand, we want to exchange the value of x and y. We want to put the value of x in y and put the value of y in x. Okay, so what happens in arg1, I will put the value of arg2, and in arg2 we will put the value of temp, which contains the old value of arg1. Okay, so this way we can exchange both values of arg1 and arg2. Okay. So let's here see out before calling swap x is equal to x, and then we call swap xy. Yeah. Okay. So I am printing the value of x and y on line number 15, and then I'm calling the function swap, in which I want that the values of x and y get swapped, and then I'm calling printing the value of x and y after calling swap. Okay. So what do you think will be the output of this program before and after calling swap? So here there are some comments. Reference variables are nothing but an alternative name to another variable. Yes, we can say it this way. You assign 32 to x first. Wherever it goes, then assign to r. Okay, I don't understand this comment, but we'll discuss the functions. Hopefully it will be clear. So before is 32 and 45, and after calling swap, the value of x and y will be 45, 32 on. Okay, let's see. Okay, let's run this program. So I save it, g plus func03, and I run it. Oops, our swap function did not work as we wanted it to. Before calling swap is 3245, and after calling swap it's the same 3245. Okay. So let's see. Let's print. Let's debug this function. Let's print these statements here at the start of this function to see whether we are actually doing the swap or not. arg1 arg2 is equal to, and just before returning we put end of swap. We print arg1 and arg2 again just to see whether the values are being swapped or not, okay, inside the function. So I compile this again. I run it again. So before, when we call in main, x is 32 and y is 45. So when we are inside swap, arg1 receives the value of x and is 32, and arg2 receives the value of y is in 45. Okay. Then the function executes, values are swapped, and at the end of the function, arg1 contains 45 and arg2 contains 32. So the values have been swapped inside the function, but outside the function, after calling swap, when I print x and y, the values are the same. So what is happening here? Because it is void. Yes, the return type is void, but it does not have to do anything with the swapping. We wanted to swap the values of x and y. Okay. So the values are being swapped inside the function for arg1 and arg2. But outside the function, the values of x and y are not being swapped. So what is happening? We wanted to swap the values of x and y. The value of x is passed to arg1, the value of y is passed to r2. So within the function, arg1 and r2 get swapped. but x and y don't get swapped. Is it logical? Is it in coherence with what we have studied until now? Very good. This comment that arg1 and arg2 have different memory locations than x and y, that is the key to the working of this program. Okay, so is it clear to everybody? arg1 and arg2 are different from x and y. arg1 and arg2 are normal variables which are created every time this function is called, and they have separate memory locations than x and y. So within the function, we swap the values of arg1 and arg2. So we swap the values in memory locations for arg1 and arg2, but they are different from the memory location of x and y. So we are not at all swapping the values of x and y. Okay, so that's why after the function, the value of the x and y are not changed. Okay, is it clear to everybody? That pass by value, when happens, the values are copied into the arguments. The arguments have separate memory locations. Arguments are basically copies of the original value. So within the function, if we change an argument from within the function, we are changing the copy of the value passed, not the original value or the variable that was passed this function. Yes, arg1 and arg2 have been swapped. Yeah, but they are separate memory locations from x and y. Okay, and those memory locations will be destroyed when the function is finished. Okay, so arg1 and arg2 have been swapped, but x and y have not been swapped. Is it clear to everybody what is happening before I proceed further and change the values of x and y? No. Uzair Rahman, what is not clear? Amla Siddiqui, don't use the word point. Okay, point, basically we use it with pointers, and we'll study pointers in next class. But right now you can use the word refer. A reference variable refers to another variable or refers to a memory location. Okay, so Uzair Rahman, what is the thing that is not clear? What is changing? The values on the stack, the memory location of arg1 and arg2 on the stack are being changed, swapped. Okay, but the key thing is that the values, the memory location for arg1 and arg2 are different from the memory location of x and y. Okay, so values get interchanged within the function swap, yes, but they are different memory locations for arg1 and arg2 than the memory location for x and y. The function swap does not change the memory location of x and y. Again, Ashar Khalid, it's the same thing. X and Y are separate memory locations than arg1 and arg2. Within the function, we are changing the values of arg1 and arg2, but not of x and y. Is it clear? The key thing to understand is that arg1 and arg2 are separate memory locations than memory location for x and y. So you guys, how do we swap? Yes, I am coming to that. But before that, we need to understand what is happening in the function currently. Okay? I hope that is clear. So we'll see and change this code to swap the values of x and y. What I will say is that these my arguments of this function, let's say this line number 4, in the definition, I would say that the arguments to my functions are not normal variables, but they are reference variables. Okay, so I'll say these arguments are reference variables. Is it clear? So now on line number 18, when I call this function swap and I pass it x and y, okay, this call will make the execution flow jump to this line number 4, the body of the function. Okay, and the arguments of the function will be created on the stack. Okay, but these arguments are not normal variables; they are reference variables. Okay, so they will be created, and reference variable have to be initialized. So here arg1 will be created and it will be initialized and it would refer to x, the memory location of x. Okay. Similarly, arg2 will be created. There will be no separate memory location for arg2, but it will be initialized and it would refer to y. Okay. So now arg1 and arg2 are not separate memory locations, but they are referring to the variables x and y respectively, which means that they are sharing the same memory location as x and y respectively. Okay, so here within the function, when I'm exchanging the value of arg1 and arg2, we are not exchanging values in separate memory locations, but we are exchanging the values in memory locations of x and y. Okay, so here after this call to swap, when I print the values of x and y, they will be exchanged, hopefully. Okay, so that's one of the most common uses of reference variables, that when passing arguments to a function, instead of passing by copy or passing by value, we pass arguments by reference. Okay, so reference arguments are not separately created on the stack. They have not separate memory locations, but they point to the memory locations of the variables that we pass to the function when we call that function. Why don't you say, yeah, we have not studied pointers yet? Okay, so bring up this question when we study pointers, hopefully in next class. Okay, so the comments before this, x and y values get assigned to arg1 and arg2, after that they get swapped. After that they get swapped, I don't understand this question. Basically in the reference, passed by reference, arg1 and arg2 are not separate memory location. They don't get the values, but rather they refer to the same memory location as x and y. Okay, so when we swap the values of arg1 and arg2, we are actually swapping the values of x and y. So basically before swapping x equal to 32, y is equal to 45. After swapping x equal to 45, y is equal to 32. However, their assigned values are still x equal to 2. Their assigned values are still x is equal to 32 and y is equal to 45. You are talking about passing by reference or by passing by value? Alishiba, your comment. Sir, you did not initialize it. Why? Okay, now that's a very good question. Assignment is obligatory for reference variables. Okay, so that's still true here. We are not initializing the reference variables explicitly, but whenever we call this function, the compiler will initialize the reference variable for us. Okay, so every time we call this function, we pass it some value, some variable, and the compiler will basically initialize this argument, the reference variable argument, to the variable that we passed to that function. Okay, so initialization is obligatory and it is still happening, but instead of we doing it explicitly, it is being done by the compiler. Okay, is it clear? Okay, so I'll just run this program to show you, I mean, if you guys don't believe my word, it is good to be skeptical of whatever you are told. So we'll just verify, because I might be making some error also. Right? So here you see, before calling x equal to 32, y is equal to 45, inside the function arg1 refers to x and arg2 refers to y. So again we print 32, 45. After swapping, the values of arg1 and arg2 have changed, and we see that after the function, the values of x and y have also been changed, because arg1 and arg2 did not have separate memory locations, but they were actually referring to the memory locations of x and y. Okay, so when we change arg1 and arg2, we actually change values of x and y. Okay, is it clear? Passing values by reference, how does it work? Others? Okay, so I hope others also got it. I mean, how does it work? What is the reference variable? How do we declare it? Why its initialization is obligatory? Okay, and what does it mean? What happens in the background? Okay, there's no separate memory location for reference variables. And how can we pass values to functions by reference? Okay, so if we want to change the variable that is being passed to a function, when you call a function, if you are passing it a variable and you want to change the value of that variable, then you should not pass it by copy or by value, but rather you should pass it by reference. Okay, so basically compile and initialize arg1 as 32. No, not as 32, not as the value. Arg1 will be initialized to x. It is not initialized to a value, it is initialized to a variable. You should, keep this distinction in mind. We can initialize a normal variable to a value, but a reference variable is always initialized to another variable. Okay, so of course they'll share the same memory location, so they will be having the same value. But in technically, we can't say that a reference variable is initialized to a value, but rather a reference variable is initialized to another variable. Okay, so everything is clear about reference variables? Like any type of variable can be a reference variable. Okay, just like here we had an integer reference variable, you can have character reference variables, boolean reference variables, etc., etc., as long as you keep or respect these rules. Okay, you have to always initialize it and initialize it to a variable, etc., etc. So by writing ampersand, we are directly accessing the address of, it's not the address. Again, you are confusing it with pointers. We'll talk about addresses when we study pointers. Okay, so right now, don't use the word point, don't use the word address. That's why I am especially using the word memory location, and I'm also referring using the word refer. So a reference variable refers to another variable or refers to a memory location. There's no concept of address right now. Is it clear? Okay, so no answer. I am assuming that the answer is yes. So one other thing I would like to highlight, in C++, sometimes certain symbols are used in different contexts and they have different meanings in different contexts. For example, this symbol ampersand. Have you seen this symbol before in C++? I did it in short way. What does it mean, short way? Bitwise operator, very good. Okay, so for AND, but bitwise AND. Okay, so there is logical AND, which is this double ampersand. Okay, and then there is the bitwise AND, which is single ampersand. Okay, so this same symbol can have different meanings depending on where we are using it, depending on the context that we are using it. So ampersand used between two variables, let's say int z is equal to x and y. Here ampersand assuming x and y have already been declared are integers. X and y in ampersand in this line means bitwise AND. Okay, but if I say int ampersand r is equal to x, then in this line ampersand is not a bitwise operator. Rather, ampersand is declaring a reference variable. Okay, we'll see this thing with other operators also. In C++, the same symbol can have different meanings depending on which context it is used. Okay, so ampersand in a declaration is declaring a reference variable, and ampersand in an expression like the one that I just mentioned is usually bitwise AND operator. Is it clear? Ampersand can have multiple meanings depending on where it is being used. We'll also, there's another meaning also, we'll see it in the next class. Okay, very good. So before ending, Uzair Rahman, you pasted some code. Where is it? Okay, Uzair Rahman, I don't see the code that you had pasted. So, okay. So is there any question right now? Reference variables, passing values, passing arguments to functions by reference. Okay, okay. So if you need to discuss something, you can always discuss it later. Any questions right now? Okay, so there are no questions. So practice this reference variable and passing values to functions by reference, and we'll see further things on Thursday. The question I asked earlier, Usman Tahir, what was that question? I'm sorry, I did not notice it, or is it has slipped my mind. Are there other situations where these are useful? You are talking about reference variables, Rafi? Missing pair, pirating, we are directly accessing the address. Yeah, but addressing, the reference variable does not involve the concept of address. Wait a minute, don't mark your attendance yet. Don't mark your attendance yet. Okay, so yes, so Rafi, mostly references are used in passing arguments to functions. Okay, more than 90% of the time. There might be other uses. I mean, I might not be knowing them. At least I can't think of them right now. But for the moment, assume that they are used for passing arguments to functions by reference. Okay. If I see another use, I'll tell you guys. Okay, so I guess that some people are getting late for other things, so you can mark your attendance now, and I'll end the session, and we'll continue on Thursday. Okay, so please mark your attendance now. Yeah, mark your attendance and you can leave. Thank you very much. I'll stop the recording.
सर ये अपलोड हो जाएगा ना